install a new patches, right? A patch or the update patches. Okay, yeah. Then we have another part called switch fabric unit. Switch fabric unit, SFU. Now this is a data plane. And what is this data plane used for? It's used for fast switching between different components of the equipment. For instance, when you're connecting the MPU to the LPU, traffic has to pass through the SFU. Okay, so if something has been realized at the MPU, where we said we run protocols, and we need to update, or rather we inform the LPU, that communication has to pass through the SFU. So the SFU provides an high-speed non-blocking data channel for data switching between different modules, for example, between the MPU and LPU. Then we have the LPU. LPU stands for line processing unit. Hapa ndio unapata ports, right? The data forwarding ports for optical, both optical and electrical interfaces. Are we together? Yeah. So SFUs and LPUs have their own management chip. So if you buy a card, let me see whether I have a website. Recently, I was shopping for some devices. Let me see whether I can show you these cards. Let me see whether I can get it. I'm just hoping I will get it. Let me show you what I mean. Recently, I was shopping for these cards, and I want to show you the diagrams. What you will find. So that is not important for the exam, just for purposes of general understanding. As it is loading, let me continue. So for example, MPU, I wanted to show you MPU, main processing unit. So you have different MPUs with different capabilities, or rather with different features. For instance, if I could start with this one, it will show you the image. Just hold on. Yeah, good. This is what I was talking of. So you purchase this card as it is, like it has its own management chip, right? Yeah. Let me share these things. They can inspire you. Maybe let me share it on the public chat. You can view them. You can observe different ones. For example, you want to buy 100 gig interface, okay, card. For example, this is an 100 gig interface card. It looks like this. Let me see the diagram. So this one is a forwarding, or that is an LPU. The category of this one is LPUI. This is where we connect the fiber optic cables, right? And you can see the maximum inakuja na ngapi? 4 ports, the 100 gig. We are buying a 40 gig interface card. So there are these three categories. We have some that can support QSFP and blah, blah, blah. This is not important, but in case maybe it inspires you in the future, you can always come back and get the right product. Okay, so those are some of the components that are found in these kind of things. Then we also have power supply. Hapa chini, is in a power module. So it comes with several power supplies for failover. Okay, and these power supplies are actually hot swappable. In other words, unaweza vuta moja itoke na urudishe ingine mpya as the equipment is running. Hot swapping, use that card. Then we have the fixed devices. So fixed devices come with everything in one box. In other words, they have the control plane, management plane, and forwarding plane, okay, in the equipment. So it is divided in two parts, that is the main control module and the switching module. Now, I said for these guys, these modular switches, the different parts here communicate this way. We said for MPU to be able to push configurations, or maybe to push data to the LPU, information has to pass through the SFU. So SFU ndio the data plane within the equipment. It's the one that is used now to push communication from one module to another module. Okay, so every time we are communicating, we pass through SFU, the switch fabric unit. All right, yeah. So to connect, remember I've said these devices have several redundant devices, redundant components. Let me use that word, redundant components. So these components help the device to be able to function whenever there are faults in any part of the equipment. For instance, up here, we have LPUs up. And down here, we have another array of LPUs. Remember, LPUs in Masama hizi vitu zinakaa hivi. These cards. So you can have several. Okay. For instance, you have the ones that we have seen that are common, these ones that have many ports. Let me show you this one. So you can see this card here is a 48 port, 10 gig capable card. Each of these ports has a 10 gigabit per second bundle. It can support 10 gigabit links, the fiber optics, right? So you can have 2 of these or 4 of them installed at different points of the equipment. Zingine weke hapa juu na zingine weke hapa chini. Now, how do they communicate? So assuming you have one LPU at the bottom, LPU number 1 and LPU number 2. So LPU number 1 will communicate with LPU number 2 through the SFU. Okay. So for instance, here we have 4 of them. 4 ziko hapo juu na zingine 4 ziko chini. So any communication between these 2 LPUs or these zones of the equipment that have LPUs will pass through the SFU. Okay. Yeah. So this is the logical architecture of how these devices communicate. Okay. Yeah. So network devices can logically be divided into 3 planes. We have said data plane, control and management plane, and monitoring plane. What is monitoring plane used for? Monitoring plane and what? Monitoring plane. And who can guess? Monitoring plane? It's used to check. Anyone? Monitoring. What are you monitoring? Monitoring the status of devices or components within the device. And also monitoring things like data rate or maybe power intake. Okay. So if there's a problem with the power supply unit within the equipment, this is a part that is used now to inform the management thing that there is a faulty component. Okay. Yeah. So control plane, you say this one sits at the MPU, main processing unit of modular switch, and it's used to manage protocols. Remember, I said it's used for protocol processing and service processing. So if you're running a protocol like BGP or you're running a protocol like OSPF, this is where that protocol is used or that runs for the calculations. For example, OSPF performs route calculations. The other is used to perform calculations for shortest path to different parts of the network. So those calculations are executed where? At the control plane. And also used for service scheduling, traffic statistics, and stuff like that, right? Yeah. And system security as well. They will be asking to see whether you can be able to tell what happens in these planes. So the control plane provides various network information, forwarding entries required by the data plane for data processing and data forwarding. So it performs the main control unit's functions and also other functions of the network equipment. Then we have forwarding plane. So the forwarding plane is used especially to provide high-speed processing and non-blocking switching channels for data. So these packets, or this data is encapsulated in packets and forwarded through the interfaces that are provided. Okay, we call it forwarding plane. It is also used to perform quality of service. Remember, we said quality of service is unfair management of traffic, which is used to help provide different user experiences, especially when accessing different services on our network. And also scheduling for services like things like maybe you want to schedule for queuing of traffic, or maybe you want to schedule for certain services to be blocked at certain times of the day. You can configure what you call time sequences for different activities that can be used now to monitor and also trigger these services whenever the threshold is met. Then we have monitoring plane. Monitoring plane, we are saying on modular switches, monitoring plane is used to provide some operations on the system. For example, it is used to detect voltage levels, and also check control of system power on and power off. It also monitors the temperature. Yes, it monitors the temperature of the equipment, and in order to control the onboard cooling fans. Okay, yeah. So if a fan unit fails, the monitoring plane isolates the faulty unit promptly so that other units remain unaffected. Okay, so it is used to check one, voltage detection. It is also used to check temperature of the equipment. It's also used for fan control of the equipment, and also it also monitors the power supply control. So these are the functions of the monitoring plane of the equipment. Let's answer these two questions. Okay. Which of the following modules on a modular switch is responsible for running routing protocols and generating and maintaining routing tables? Anyone? Anyone? Answer is what? Yes, Samuel. Someone else to attempt?
MPU.
Yes, correct. MPU, correct. Now, second question says, when forwarding service packets, remember service packets are for the different services that run in the equipment. Does a high-end modular switch query forwarding entries from the MPU when forwarding service packets? Service packets ni kama, for example, traffic ya mtu ana download information. No, okay? Yeah. So we say the forwarding plane has its own management chip. Okay, so the management chip is used now to keep the forwarding entries, or rather the forwarding mechanism. So what the MPU does is the MPU provides the logical way in which the equipment is supposed to forward. So it creates kind of a template. Then the template is pushed to the forwarding plane. Okay, yeah. So the forwarding entries are rather the switch will not query the MPU for any forwarding. It will query the forwarding plane. It has its own independent way of checking. Good. Any questions so far? Any questions? All right. The other requirement that we expected here, I'll be showing you this requirement in PDF. The other requirement that we expected to learn is VLANs. No. I think I skipped something by mistake. TCP/IP protocol basics. These ones I will expect you guys to look at them. They are easy. They are not difficult to learn. TCP/IP and UDP. For instance, let me summarize this one very fast. Use this one for. Okay, so we expected to learn something about them. So I'm going to just give you an overview of the TCP/IP protocol stack. TCP/IP protocol. It has 5 layers. Okay, so the TCP/IP IP protocol stack has these layers. At the top, we have the application. Let me use this one. We have the application layer. We have what other layers are following? Transport. We have network layer. We have data link and the physical. Okay, use that. Okay. Yeah. So here, these are 1, 2, 4, 5. Okay. Yeah. So I'm going to be measuring, using this to describe what we are expected to learn here. Okay. So we have ARP, IP, NAT, Telnet, FTP, DHCP protocols here. So the first two protocols, that is TCP and UDP, these are protocols that run at transport layer. And they're used to define the different applications that run at the application layer. So the transport layer and the application layer work together. Those ones work together, have to work together. For instance, you're running HTTP, which is used for? HTTP is used for what? Anyone? HTTP. Okay, okay, I'm getting different reactions. So this one is used for transferring the transfer of web pages from a server to a client. Okay. For instance, when you access a website, the protocol that is used to transfer that page, that information, web information from the server to your machine is HTTP. We also have HTTPS. So these applications are mapped at the transport layer using different ports and different protocols. The protocols that are dominant here are that are found here are TCP and UDP. Okay, TCP and UDP. So depending on the nature of the service, or rather depending on the nature of the transport activity, we use either TCP or UDP. For instance, we have services that require transport efficiency and other services that require transport reliability. Those are two different terms. For transport efficiency, we mean that this service has to be uh, executed very fast. We are looking for speed, efficiency. Okay, yeah. But for reliability, we are looking for services that can assure us that that data is going to be transmitted to the other end successfully without failure. So you have transport reliability and transport efficiency. So for HTTPS, for example, we need this data for us to be able to utilize, or rather for consumption. This is something that will require transport reliability, and that is TCP. So TCP is used for transport reliability, and UDP is used for transport efficiency. For instance, maybe you want to stream videos, or maybe you want to send files at high speed. When you're downloading something, maybe you're watching something from YouTube, YouTube doesn't care whether you get it successfully or not. Okay, they don't care. Either you have a poor network down there, they don't care. In other words, they want you to access the service at the fastest possible speed, and that is UDP. Right. The network layer, data link layer, and physical layer, these three layers are used for network to network communication. For instance, you're communicating with a Google server, a server at Google. So you have your own local network within your enterprise campus network. And there's a network that is connecting the server where that service is running. So to ensure network to network communication, we need these first three layers. Network, that is physical layer, data link layer, and network layer. Okay. So once the network is set, now we move to host to host. Host to host, we mean now it's application layer and transport. These ones are used for host to host communication. Okay. Yeah. The ones that are below, network to network communication. So we have protocols that are involved here. For instance, at the network layers. Network layers, I've said, are the physical, data link, and network layers. Let me use that one for network to network communication. So for a switch to communicate with a router, we need to have a protocol implemented there, right? Yeah. So some of the protocols include one, HARP, Address Resolution Protocol. This is a protocol that is used to map IP addresses to MAC addresses. MAC stands for Media Access Control. Okay, so to map an IP address to a MAC address, we need what we call Address Resolution Protocol. All right, yeah. So R works here. Then we have another protocol, IP protocol, Internet Protocol. Internet Protocol works at the network layer. And this one is used to provide one, a logical addressing for different devices that use the network layer. Okay. And two is used to provide the forwarding of packets on a IP routing on an IP routing network. Okay. So it's used to route packets, and as well as it's used to assign, or rather, we use it to assign addresses, logical addresses to hosts. For example, your computer, when it's accessing the internet, it will need an IP address, a valid IP address. Okay. Yeah. We talked of NATing. NATing is a protocol that is used to map a private IP address to a public IP address. What scenarios do we use NATing for? For instance, within a local area network where you're using private IP addresses, you will need to access the internet. The devices that are connected on the internet or on the public network use public IPs. Okay, so NAT comes in to map a private IP address to the public IP. Okay, so here we implement NAT. So normally the devices that sit at the egress part of your network are the ones that are responsible for NATing. Assuming this is a firewall that is connected to your ISP, or maybe it's a router that is connected to your ISP. That's where you implement NATing. We also have types of NATs. Types of NAT. We have what we call easy IP. Easy IP. These are areas we need to revise. We have easy IP. We have NAT server. We have NAP. Okay. Yeah, go and check HCI level, you will find this. Easy IP is the most common currently, in that we can map the same public IP to different or to multiple private addresses. Okay. Yeah. It also supports port address translation as well. So we map both the IP address and also the port at the transport layer. Supports both. NAT server is used whenever we have a server that is hosted within your local area network. So if you have a server that is supposed to be accessed in the public, or rather on the internet, and you are hosting it internally with a private IP address, that server IP can be mapped to the public, okay, with a public IP address, so that users who access the service from outside your network can be able to access it. We call that NAT server. Okay, go and read about types of NAT. Now we have Telnet. Telnet is a remote management protocol, which is used to manage devices remotely on the network. I demonstrated to you how it works, how we use it. We use these terminal emulators to create Telnet sessions. We come to Telnet here. It runs on port number 23. Then you specify the remote IP address that you want to manage. You put your IP address here. Okay. And so is SSH. SSH and Telnet are used for remote logging management. Then we have FTP. FTP is used for file transfer protocol. It's a file management protocol. It runs on which ports? Anyone? Which ports? Which ports are used to run the FTP? Which ports are the transport layer? Anyone? FTP. Yeah, it runs on port number 20 and 21. Yes, thank you. So FTP runs on port number 20 and 21. Kindly read about this. It's HCIA. So one is used to establish the connection. And remember, this is TCP. FTP runs with TCP. Okay, TCP. So for TCP operations, or rather for TCP supported services, we have to establish a connection first. Remember, TCP you said is transport reliability. So first we establish a TCP session, and to establish a TCP session, we normally refer to that process as three-way handshake. Sindio? Three-way handshake. Okay. And to close the session, we establish the four-way handshake. Go and read about it. Three-way handshake and four-way handshake for terminating a TCP session. So every TCP session, we have to establish the connection first using the three-way handshake. Go and read something about the three-way handshake and which type of packets are exchanged during that time. So to establish the session, the FTP session, we use port number 20, and to send data, we use 21. Let's go and read more about that. Then we have DHCP. DHCP stands for Dynamic Host Configuration Protocol. This is a protocol that we use to assign IP addresses automatically on host devices. Okay. Unlike in the past, there's a time I found in the school I was studying, we used to go and get IP addresses assigned to our laptops, static IP addresses, and it was cumbersome. Can you imagine a campus that has like 30,000 students and you are assigning IP addresses? That is very crazy. So DHCP comes in handy. It provides centralized IP address assignment and management. Okay, yeah. DHCP runs using which port number? Anyone? Port number? At transport layer, which port number? Hurry up. Anyone? DHCP? Port number 67. Is this 67? Who else can support it? Yes, it runs at port number 67, and that is on the server. The server runs on UDP. So remember, DCP is UDP, not TCP, right? Yeah. DCP is UDP, port number 67. Okay. And we have some packets that are involved during DHCP negotiations between a client and a server. So a client requests for an IP address, and then these IP addresses are assigned by sending the information using certain packet types. Which packet? We usually have the initial DORA. So the packets are known as discover packets. Discover, then is an application tool. Discover, offer, request, acknowledge. The type of packet that is sent at DORA discovery stage is usually broadcast. Okay, the server sends the broadcast. Then the offer packet is usually unicast. Unicast. Then the request packet is a broadcast, and the offer packet is a unicast packet. Then there's usually a question which asks, why is the request packet a broadcast packet? It's because it's used now to inform other DHCP route servers within your network that the client has decided to use a particular IP address. Okay. Remember, you can have multiple DHCP servers on the same network. Okay. Yeah. Now let's look at Ethernet switching basics. I'm going to go back to my PowerPoint. Okay. We have a few minutes. Let me take advantage of them. We said 5:30 is the day, is the time. Ethernet is one of the protocols. So Ethernet is one of the protocols that is one of the most popular protocol. Let me use that word. Found at the data link layer. Ethernet. Okay. Yeah, it's defined by IEEE as the protocol that is used now for the exchange of data at the data link layer. So the standard is usually described as 802.3. Okay, 802.3 is the standard that is defined by IEEE to connect devices on a local area network. We call it Ethernet. Okay, it comes in different other flavors. Others protocols are also going to be defined under the protocol Ethernet. So we have a device here we call the network interface card. These are popular device we find in our computers, in our laptops. So our mobile phones have them. And is a key component that's used to connect a network device such as a computer or switch or router to an external network. We call it the network interface card. So a network interface card has a unique MAC address. Okay, it has a unique MAC address which is embedded on it. We call it network port in some. Okay, yeah. So it has a unique MAC address which is used now to identify the device on the network. Now let's look at Ethernet frame. Now, at data link layer, we send information using what we call frames. 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 Okay. Frames are the unit of data. The data unit. We call it the protocol data unit. We call it frame. Okay. Yeah, we use it at that is the type of data that is sent at a switch level, at data link layer. So frames actually rather usually form now the protocol data unit, which describes the components that are, rather describes the elements that are carried within this data unit. One of the data unit that is carried, or the element, is the user data. Okay, yeah. So the user data usually combines something like a packet and the data that was populated or that was generated at the application layer. So at the application layer, we generate data. Then we channel this data to the transport layer, where at the transport layer, we add segment information about the destination port and source port. Once it's sent to the network layer, we form the packet, which has the information about forwarding, that is the destination IP address, and also the source IP address as well. So once it gets to the data link layer, we just refer to it as user data, which combines the packet header, the transport header, or the TCP header or UDP header, and the data. So, yeah. So here we add forwarding information that is in the form of MAC addresses. So we have the destination MAC address, the source MAC address. Okay. Something about the Ethernet frame is that we have two types. We have the Ethernet type 2, and then we have the IEEE 802.3 format of an Ethernet frame. Now, this is how they differ. So, the IEEE 802.3 includes now the logical link control information. We also have the snap information here, and user data and frame check sequence. So, frame check sequence is used for, you can see it's appearing on both, is used for maintaining the integrity of data forwarding. The frame, or rather the Ethernet frame, is the only element that can assure reliable data transmission on a network. So FCH helps now ensuring that packets or other frames are forwarded in a reliable manner, or to ensure reliability of forwarding of frames. So whenever frames have been received incomplete, then is this part of the this part that is used now to request the transmitting device to send or resend the information again. What is a MAC address? What is a MAC address? A MAC address is a physical unique address which identifies a network interface card. So it's unique. It's used to identify a network interface card. And it's globally unique. So MAC addresses are usually assigned by manufacturers, and manufacturers get these codes from the IEEE, that is the Internet Engineering, the Institute of Electrical and Electronic Engineers, which assigns what you call organization unique identifiers. So in every MAC address, we have what you call the organization unique identifier, which identifies a particular manufacturer or a particular organization. So they are globally unique. What is the difference between them and MAC address and IP addresses? IP addresses are logical. That is a relative in that they can change. You can change them. They're also unique. So both carry the uniqueness in that they are unique, but not globally for IP addresses. MAC addresses are globally unique, but IP addresses are not globally unique. And IP addresses are assigned based on the network topology. MAC addresses are assigned based on the manufacturer. I've said each manufacturer has its own unique organization unique identifier, which is assigned by the Institute of Electrical and Electronics Engineers. Okay. Yeah. MAC addresses appear as a 48-bit value, and they're expressed in hexadecimal format, number format, with groups of 2 each. And they have this kind of format, as you can see here. Okay. Yeah. So there are 48 bits, that is 6 bytes inside, and they're expressed in hexadecimal. Your understanding on how to convert numbers from hexadecimal to binary is required so that you can understand how MAC addresses are formed. We have different classes of MAC addresses. We have unicast MAC addresses. What are unicast MAC addresses? These are MAC addresses that are used to identify host devices and host interfaces and devices, other interfaces of devices like routers or layer 3 interfaces. Okay. In other words, they carry the OUI, which we have called the organization unique identifier. Then we have the company ID, which is used now to provide serialization of devices as they've been manufactured. Another unique feature of unicast MAC address is that the first 8 bits are usually zeros. Now let's look at multicast MAC addresses. So a multicast MAC address does not have an organization unique identifier. Okay, yeah. What are they used for? They're used for multicast communication. We said multicast communication is where we send packets from one device to other devices that belong to the multicast group. Then we have broadcast MAC addresses. Broadcast MAC addresses have all ones. All the 48 bits are ones. In other words, we convert them into hexadecimal, you'll get this. So this is a broadcast MAC address. What is a broadcast MAC address used for? It's used to send packets, or rather not packets. It's used to send frames from a switch to other interfaces, especially when the destination MAC address is not known. Okay, so let's look at the working principles of switches very fast. So switches have these mechanisms. Let me skip these two. So a switch can flood information, flooding. A switch can forward information. This is for unicast forwarding. Flooding is for broadcast forwarding. And a switch can discard information. Okay, yeah. As Enrique is asking something about MAC addresses and IP addresses. MAC addresses are physical. MAC addresses are physical. IP addresses are logical. I hope that is clear. So MAC addresses are usually globally unique. Your laptop network interface card has a unique global MAC address, which is not similar to any MAC address in the world, or which does not identify with any other MAC address in the world, globally unique. But IP addresses, you can use the same IP addresses on different networks, different physical networks. Okay. Yeah. Okay. So when do we flood? So if a switch receives a frame whose destination MAC address is not known, it will flood to the other ports except the port where the frame was received. When does a switch forward? If the destination MAC address of is on the same switch, or rather in the MAC address table is on the same switch, then the switch forwards to that particular port. When does a switch discard? If a switch receives a frame whose destination MAC address is the same as the MAC address in the MAC address table where the frame was received, then it discards. So if you realize, the switch realizes that it has received a frame, but the destination MAC address is the same as the interface that has been learned on that particular port, according to the MAC address table, then it will discard. It will not allow it. So I wish to stop at this point. We have looked at quite a number of issues here. We have looked at Ethernet switching basics. We have looked at TCP/IP protocol basics. Okay, and we are going to pick from there on Monday, and we are going to continue with VLAN. So on Monday, I will be super fast because we'll have gotten an idea of what to expect. So I want to wish you an happy Jamhuri Day. Jamhuri Day tomorrow, and also a nice weekend. Any questions? If you have a question, you can ask at this point. What time will we meet on Monday? From 8:30. 8:30. I will assume everyone would have managed to get to their comfort and settled. Can someone still sit for HCIA exam? Yeah, if you have a voucher, if you have an active voucher, kindly take the exam. Yes, AM, 8 a.m. in the morning. Someone's asking whether the meeting was recorded. Oh, unfortunately, I was not able to record because I didn't have I think someone was recording. Who was recording? Someone was recording, yeah. Someone was asking where do you get the voucher? This one is something you should have been assigned Kitambo by your academy. So at this point, it's very difficult to get a voucher. How about the notes? I will get to the group. Everyone join the group. I will share the notes there. Yeah, national finals is still online. Yes. Yeah, we will use the same link. We'll use the same link all through. Robert, at the moment, you cannot get an exam voucher. This is something that you should have been assigned at your academy. You did not get vouchers for preliminary. Can we? At this point, you can't get vouchers. Will there be certificates after that? If you qualify for nationals, you'll get a certificate. If you qualify for regional, sorry, if you qualify for regional, you'll get a certificate, and also you'll get a present. Will the boot camps be taking the whole day? Yes. I'm wishing that we take Monday and Tuesday, we complete everything, so that everyone can have ample time to prepare. So it means I need to pay to get certificate. Yes, you can pay. That's another cheap way of getting through. Shortcut. Yes, you can pay. If you pay, no problem. It's actually 6,000 for HCIA. What about people who didn't get the voucher? You can. Let's use this option of paying. It's only $200. Could the classes be recorded for those who have Cool and yeah, sure. I will. Next on Monday, I'll be recording. Yes. How many questions will the national exams have? I think you'll take them. You can take many questions, as many as you can. Bora ufanye zinakwaka 60 questions. They will pick the best. So there are no certificates for even participating in the national finals. Well, if you pass, if you're among the top six, we'll give you a very nice certificate. It will be actually awarded to you by the Minister for Education, and you'll get a present that day. You'll get probably a laptop, a nice mobile phone. That's exactly what I am paying for all that. Yes, if you love yourself, you want to go to China. This is the stage that is difficult. Let me tell you, this is the stage that is difficult. The other stages are just very smooth. Can the academy get a voucher now, or it's too late? It's too late. Academies right now have no vouchers. There was shortages. What is national level? We have a tie. That's why I said your participation today is very important. We'll look at other factors. Don't worry. Where are the exams in the competition website? Yes, you'll get it on the competition website. You'll also get a link. An academic. At the moment, Steve, it's impossible unless you purchase. You can register. You can request for a voucher, a discounted voucher. Utapewa discount ya 70%, alafu lipe hiyo pesa ingine. Just 6,000. Yeah, you can still apply and do the exam. Si ngumu, preliminaries. You mean an exam for this, we'll do the same way. Yes, we'll do it the same way we did preliminaries. How can we purchase? Conduct your academy. No, just go to the Huawei website, go to the Huawei talent website, and then log in. Then under exam voucher, you apply for a discounted voucher. You can your process hapo. Once you apply, it enter through. Alafu, you'll come back and check, and my vouchers, you'll be able to see it. Then you book the exams. When you book, during booking, it will redirect you to the Pearson VU website, where they will ask you to pay the $200 up. Then you can transfer money. What about answers for preliminary for revision purpose? uh, Unfortunately, there are no answers. They don't share them. Okay. Yeah. So it's 6,000 per person or per person. Yes, per person. Remember, the voucher is 20,000 Kenya shillings. So you have been waived 14,000. So you just pay 6,000. If you are from an academy, that is. Can you negotiate to increase the number from 6 on our behalf? I'm not getting a question. Oh, the number of six participants. Okay, well, it all depends with the budget for this year if the Huawei is willing to sponsor. Because remember, you'll go to South Africa, right? Yeah, and you can imagine sponsoring more than six. Is a tall order in every category. Remember, we have 4 categories. So Marie says, why is it so difficult to install ENSP? ENSP requires that you have a good machine. Ensure you're using Windows 10. Don't use Windows 11. Will you share some past national finals exams for familiarity? Um, I what I would share is HCIP dumps. Yeah, but it's not that hard. The example is not going to be that hard. What we are going to cover is actually what you might expect there. Victor says we have upgraded our machines to 11. The problem with Windows 11 is that it's not compatible with VirtualBox version 5. So you'll have a problem. Kelvin Windows is still using Windows. Well, you can temporarily go back, take it to Windows 10 for purposes of understanding, then bring it back. Kelvin, which one? Where are you installed? Where have you installed your ENSP? Still using Windows on a Linux PC? Yeah. Bruce Willis asked, does it mean 6 in the network track and 6 in other tracks? Yeah, 6 in each category. Oh, Kevin is using Zoring. Yeah, okay, yeah, sure. Everyone, you can go try that. It's a nice operating system. Okay, if no questions, then we can call it a day, and we can continue next week. Okay, welcome. I all wish you the best. National finals, no practical. Robert, yes, you can do the exam. Bruce, no. It is a totally different level. So the points you're going to get, come on, you a 900, strive for 900 now, another 900. If you have a certification, that's why I was saying if you have a voucher, do the exam because it will give you more points. For example, HCIA, you get 50 points. HCIP, you get 100 points on top of what you will score.